Well, hello and welcome back. This is Mr. DeMeo, and we are going to be looking at section 9.5 today, which is trigonometric ratios. That's how you pronounce that word, trigonometric ratios. There's really two goals to this section. The two videos that you're going to be watching are going to focus on both of them on goal one, which is finding the sine, the cosine, and the tangent of an acute angle. So we're moving away from special right triangles, and we're dealing with some new vocab, sine, cosine, and tangent, and then eventually we'll move on to finding trigonometric ratios in real life problems, but we'll come to those later on in the week. So throughout this video, you should be using the pause option. You need to be taking notes, so probably getting these two goals down along with the section heading to start off with. Pause the video until you get those, and then come back. I'll try to give you a little bit of a break so you'll know when to pause. And now would be a great time to pause and get these headings down. All right, so again, some things that you're probably going to want to get into your notes is the definition of a trigonometric ratio. Here it is right here. I'll point it out to you with my little thing. Trigonometric ratio is a ratio of the lengths of the sides of a right triangle. Very simple. We've talked about trigonometry being the Greek word for measurement of triangles. And these three words, sine, cosine, and tangent, you've probably seen on your calculator before. We'll deal with the calculator later. But sine, cosine, and tangent are just three specific ratios that we look at. So again, you probably want to get this down into your notes. So take a second now to get this whole section right here up top into your notes. All right, now that you've gotten that, let's look a little bit at the figure down here. Let's slide it up to the top so you can see it. The three trigonometric ratios that we're talking about, sine, cosine, and tangent, are simply the ratios of the sides of a right triangle. So we're going to look specifically at angle A, and the angle can change throughout the problems, but we're going to look at angle A down here. And if you were standing on angle A and looking at the triangle, we know that across from angle A would be side A, across from angle B would be side B, and then across from angle C, the right angle, would be the hypotenuse C. So we're going to deal with standing at angle A, and little a up here would be considered the side opposite. B would be considered adjacent to angle A. It's the one next to, but not the hypotenuse. And then finally, the hypotenuse is obviously the hypotenuse. The trigonometric ratio for sine A, is simply the ratio of the side opposite angle A over the hypotenuse. So the ratio of little a over C would be the sine of A. That's the trig ratio. Cosine, the cosine of angle A, is the ratio of the side adjacent to angle A, which is B, over the hypotenuse, so B over C. And then tangent is the third ratio, and if you kind of look at, there's only three ways to put these three letters together. The side opposite angle A over the side adjacent to angle A, which would be A over B, is what tangent is. So again, I would take some time right now to make sure that this entire chart, along with the figure, gets into your notes. And then, pause it and come back when you're ready. We're going to do some examples. All right, a little mnemonic device that will help you remember these ratios, that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, is the word SOHCAHTOA. And I'm going to spell it out for you and show you exactly what I mean. So sine is opposite over hypotenuse. So cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. It's probably one of the more famous mathematical mnemonics. So again, you have sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. So SOHCAHTOA, which I like to think is the Indian prince of math, Native American Prince of Math, SOHCAHTOA will help you remember the relationship between the sides and the trigonometric ratio. All right, so let's take a look at an example here. So example 1, again, I would pause at this point and get this into your notes along with the directions, the two triangles, the large triangle and the small triangle. So take a second and jot these down, and then I'll show you what we're going to do with them. All right, one of the things that you might notice is that the triangle on the left is actually twice as big as the triangle on the right. All of the sides on the left are double, so the hypotenuse of 17 is double 8.5, 8 is double 4, 15 is double 7.5. So corresponding sides are twice as big with a scale ratio here of 2 to 1. I'm not so concerned with that. I'm more concerned with generating the ratios for angle A. So specifically for angle A, we want to generate sine, cosine, and tangent of angle A for both the large and the small. So what I'm going to do is divide the screen down the middle. And we're going to have the large and the small triangle. Let me slide this up to give myself a little bit of extra room to do that. All right, so if I want the sine of angle A for the large, what I need to do is write down sine, S-I-N, of angle A. Now sine is the opposite over the hypotenuse. So in this case, the sine of angle A would be the opposite side. So opposite angle A is going to be the 8. Hypotenuse is going to be 17. So the sine of angle A is the ratio of 8 to 17. The cosine of angle A. So cosine of angle A is going to be the ratio of the adjacent side. So the 15 over the 17. So 15 over 17 for cosine. And then the tangent, tan angle A, is the ratio of the opposite over the adjacent. So opposite of A is 8, and adjacent to A is 15. All right, so there are sine, cosine, and tangent for the three, for the angle A in the large triangle. On the right-hand side, we're going to do the small. Now I'm going to do this a little quicker. Sine of angle A for the small. So sine A is 4 over 8.5, opposite over hypotenuse. Cosine of angle A is adjacent 7.5 divided by the hypotenuse of 8.5. And tangent of angle A is opposite over adjacent, so 4 over 7.5. Now, if you don't have a calculator with you, now would be a great time to grab one, because I do want to show you something. If I were to look at the fractions reduced to a decimal, 8/17, 15/17, and 8/15 on the left-hand side, literally just take your calculator and do 8 divided by 17, 15 divided by 17, and 8 divided by 15. You would get approximately the following numbers. So 8/17 is approximately 0.471. 15/17 is approximately 0.882. And 8/15 is approximately 0.533. That's what happens when you change those ratios to decimals. If you look at the right-hand side, the small triangle, and you do 4 divided by 8.5, 7.5 divided by 8.5, and 4 divided by 7.5, it shouldn't be too shocking that in fact you get the exact same ratios. That 4 divided by 8.5 is approximately 0.471, this is approximately 0.882, and the last one is approximately 0.533. And why that shouldn't be all that shocking is, although the size of the triangles is different, we know that the corresponding angles are actually the same. That angle A in the left-hand triangle and angle A in the right-hand triangle don't change angle measures simply because the figure got smaller. That the angles stay the same, they're congruent. The sides have changed, though, by a scale factor of 2. So what this does show is that two triangles with the same angle measures will in fact have the same ratios for sine, cosine, and tangent. again, you should get this down in your notes and make sure that you understand it and you've tried it on your calculator to verify that in fact this is what you got. All right, and move on to the next example. Example 2 says find the sine, the cosine, and the tangent of the indicated angle, and we're going to do this for angle R. We want to find the sine, the cosine, and the tangent of angle R, and we'll give both the exact value, the ratios themselves, as well as a decimal approximation. If you want, pause the video right now and maybe give it a shot on your own. See if you can find sine, cosine, and tangent of angle R as both a fractional value and then a decimal, and we'll go to 3 decimal places. We'll go to the nearest 10,000th. I'm going to do it now so you can come back and check when you're done. So sine R is going to equal the opposite over the adjacent. Now the opposite of R is down here at 12. I'm sorry, I just said opposite over adjacent, opposite over hypotenuse. So we want to do 12 divided by 13 for our sine value. 12/13ths, which is approximately, as a decimal, 0.923. Cosine of R is going to be adjacent, which is 5, divided by 13, which is approximately 0.385. And then finally, tangent of R, so tan R, do apologize for the writing, it's not the easiest thing to write on. Tan R is opposite, which is 12, divided by 5. And 12 divided by 5 is actually a fairly large number, and it's not even an approximation. It comes out to exactly 2.4. All right, so there are your sine, your cosine, and tangents of angle R. Let's try one last example. Again, maybe you should pause this and try on your own, but let's try to find the sine, the cosine, and tangent of angle B. So the sine of angle B would be opposite, which is 3, over the hypotenuse, which is 5, and 3/5 is actually exactly 0.6. Cosine would be 4/5, which is exactly 0.8. And finally, tangent would be 3 over 4 for angle B, which is exactly 0.75. Hopefully you were successful at those, getting sine, cosine, and tangent of that angle. One last thing that I do want to point out is that we never actually take the sine, the cosine, or the tangent of the right angle. So you're never going to be asked that. And the reason why is when you have the opposite side and the hypotenuse, when you're looking for sine, the opposite and the hypotenuse are actually the same piece for a 90-degree angle. So it's impossible to have distinctive ratios that we look at. So we will never be dealing with the 90-degree angle. It will be one of the 2 acute angles. And again, if you go back to the original start of the notes, we did talk about only the acute angle, finding the acute angles ratios for sine, cosine, and tangent. All right, if you need to pause and go back and look at any of these, do so. If not, if you're feeling pretty comfortable, you can move on to trig ratios 2 video. Thanks for watching, and I'll talk to you later.